Yes. So the screen is visible, and am I audible? Yes, confirm. Okay. So we will start with the Unit 4 from signal and system, that is random signal and random process. So as I was telling that this chapter is basically more mathematical as compared to the previous chapters. Also, the previous chapters you have studied like Fourier series, Fourier transform, that are also mathematical. But here you will study more about the probability and non-deterministic signals, that is called random signals. Okay. So first we will begin with the probability. What is basic approach of probability, different approaches of probability. We will study conditional probability. Okay, you might have studied in your 10+2 also about the conditional probability based theorem, independent events, like that. So we will first revise all those things. And after that, we will continue with the random variable part. So what is discrete random variable, continuous random variable, what are the probability distribution function, cumulative distribution function, density function, etc. Further, we will move to the joint redistribution, density function, and after that, we will start with the random process and different types of random process based on their stationarity. Okay. So let us begin with the basics of probability. So you all know what is random experiment. So can anyone tell me what is random experiment? What do you mean by random experiment? Yes, random experiment. Yes, anyone who knows about this, just unmute yourself and answer. Okay. So random experiment is an experiment whose outcome cannot be exactly predicted. What will be its outcome? Okay, like rolling a dice, we will get either 1, 2, 3, 4, 5, 6. Now exactly one will come up or what outcome will come up, we cannot predict that. So this type of experiment is called random experiment. Now, after random experiment, we have to know about sample space. So here S, what is written here is S, a set S. So it is a set of all possible outcome of that experiment. Okay. Now, here you can see in this Venn diagram, this is sample space S. This complete box is your sample space. Okay. Now here this star marked are the elements of sample space. Okay, or we can say the outcomes of random experiment. Okay, so here you can see two different sets. Here the first set is, you can say, Y, which has only 3 elements, and another set is X, which has 5 elements. Okay, so there is no intersection between these two sets. So these two sets are called mutually exclusive events. You might be aware about the mutually exclusive events. You have already studied in your 10+2. Okay, so these are some basic concepts related to sample space, events, outcomes, and mutually exclusive events. Now let us begin with the different approaches of probability. So probability of any element is denoted by this notation, that is P of X, where we are considering as X as an event. Okay, so there are 3 different approaches to the probability. The first one is classical approach, second is frequency approach, and third and the latest one which we are going to apply is axiomatic approach of probability. Now, what is classical approach of probability? Let us consider an event X. The probability P of X in case of classical probability is given by P of X is equal to N of X upon N. Okay, let me clear one more thing. All the content of this class is taken from the book Schumann series for signal and system, and also your syllabus is designed accordingly. So you can also refer that book Schumann series, signal and system by Schumann series. Okay, so event X, so the probability of X in case of classical probability is the ratio of N of X to the N. What is N of X? N of X is number of outcomes of event X, and N is the total number of outcomes in sample space that are mutually exclusive. So this is the classical approach of probability. The next is frequency approach. So in case of frequency approach, the probability of x is given by limit n tends to infinity, n of x upon n. Here n and x are defined same as the classical approach. Just one thing, that n is tending towards infinity. Okay, so the number of outcomes are approximately infinity or very high, like that. Okay, now let's come to the recent approach, that is axiomatic approach of probability. Now, the classical approach has some limitations. Okay, so axiomatic approach recently come into the picture in I think 20th century only. Okay, so here the probability of any element x or any event x, p of x, depends on the following postulate. The first postulate says that probability of any event is always greater than or equals to 1. As you already know about this, probability cannot be negative. Second is probability of sample space is equals to 1. So these are two postulates. The third one is for any two events x and y mutually exclusive, the joint probability, what I'm saying, joint probability of x union y is equals to probability of x plus probability of y. So indirectly what we can say, that probability of x intersection y is equals to 0 for mutually exclusive events. Okay, now if it is not mutually exclusive events, then in that case joint probability of x union y will be probability of x plus probability of y minus probability of x intersection y. This you have already studied in your 10 plus 1 and 10 plus 2 in sets also, set theory also, you have studied all these things. Okay, so you have to know about some basics of this axiomatic approach. Now let's move to the conditional probability. Now what is conditional probability? Let us consider you have to find the probability of any event x, and you know that event y has already been occurred. So it means you have given that event y has occurred and you have to find the probability of getting event x. So in that case it is denoted by probability of x given f. So we will read this expression as probability of x given y. Now, to find this conditional probability, first we will calculate the probability of x intersection y and divided by probability of y. So this will give you the conditional probability of x given y. Okay, now we already know that probability of any event is always greater than 0. So p of y should be greater than 0. It cannot be equal to 0, because if p of y will become 0, this conditional probability will not be defined. Okay, as denominator will become 0. Now when we multiply this p of y with this term, so we will get the probability of x intersection y, and it will be equals to probability of y given x into p of x, or we can also write it like this, probability of x given y into probability of y. Now this is the multiplication theorem or multiplication rule in case of probability theory. Okay, now one more thing you should know about this, that conditional probability of x given y will always be equals to or greater than probability of x. If x and y are independent events, then in that case probability of x given y will be equals to probability of x. So this equation is valid only in case when x and y are independent events. Okay, so these are the some basic terminologies related to the conditional probability. Okay, is it clear till this part? Everyone is clear? Is there any doubt? You can unmute yourself and ask me the questions. Yes. Yes, those who are attending the class properly, kindly acknowledge. Unmute yourself and acknowledge this. Okay.
No doubt, sir.
Okay. Because your chat box screen is not visible to me, so I can only get acknowledgement from you by your voice only. So just unmute yourself and tell me whatever you doubt you have, and is it clear or not? Okay, so let's move to the next concept, that is joint probability. Now the joint probability I have already discussed in the axiomatic approach of probability. So probability of x intersection y is equals to probability of x plus probability of y minus probability of x union y. So also we can, if we shift this term here, we will get the equation for probability of x union y. So this is also an important equation which will be used to solve the numericals. Okay. Now the next part is independent events. So already discussed about this. X and Y are statistically independent. It means the event X is not dependent on Y, and vice versa. The event Y is not dependent on X. Such an events are called independent events. Let me explain you the independent events by an experiment. Consider a box, and the box contains 5 red and 6 black balls. Now I'm taking 2 balls out of this box in 2 different situations. In the first situation, I have selected one ball and noted down the ball. And suppose I'm taking event X, that taking event X as getting a red ball. So in that case, probability of X getting a red ball will be 5 upon 11. Now, if I'm not putting this ball again to the box, and now I'm getting one more ball from this box. So I'm drawing one more ball from this box, and the first ball is not replaced in the box. So in this situation, the number of balls in the box will be different. And suppose the first ball drawn from the box was red. In that case, the number of balls available now in the box is 4 red and 6 black balls. So the second ball drawn from that box, the probability of second ball drawing from that box, suppose we are considering it as y, so probability of y will be 4 upon 10. So in this case, the ball drawing from the box is red, is the probability is 5 upon 11, and the second ball drawing from the box is 4 upon 10 when we are not replacing the ball. Now consider the second situation, the same situation where we have 5 red and 6 black ball in the box. I am drawing the first ball. Okay, now what is the probability of that? The first ball drawn is red. It is 5 upon 11. Now I am replacing the ball, again placing the ball to the box. And now I am drawing again another ball from the box. Now what is the probability of getting the red ball in the second case? Tell me, what will be the probability of this?
5 by
Yes.
11, sir.
5 by 11, it will be same as the previous one. So here the event y is not dependent on x. It is not dependent on x. It is independent of x. But in the first situation, event y is dependent on x, because it depends whether the drawn ball first was red or black. So these situations are dependent events, and these situations create independent events. So this is the difference between independent and dependent events. So this is the mathematical condition. Probability of x given y is equals to probability of x. It means x doesn't bother what was the previous event y. Okay, y has happened or not happened, it does not depends, it does not affects the probability of y. And similarly, probability of y given x is equals to probability of y. In another way, for independent events, we also write it like this: probability of x intersection y is equals to probability of x into probability of y. As I have discussed the multiplication rule of probability with all of you just before, that probability of x intersection y is equals to probability of x given y into probability of y. And in case of independent events, this probability of x given y is equal to probability of x. So we can use this equation also to represent two independent events x and y. Clear? Okay, so can we move to the next slide? So anything you want to note it down, you can do it, or you can take a screenshot, because just after few basic concepts, we are going to start with some of the numericals, and that you all have to solve. Okay, so after conditional probability, just a second. Yes. So after conditional probability, we will move to the total probability and Bayes theorem. Now, what is total probability? Let us consider a random experiment, and this particular box shows the sample space of that random experiment. Okay. Now, this sample space is divided in four parts. That is x1, x2, x3, and x4. Okay. Now consider an event of y, which is basically a combination of x2, x3, and x4. Okay. Now here you can see that I can write the event y as y intersection x2, because y and x2 has some common elements, union y intersection x3, union y intersection x4. So y can be represented like this. So if I want to calculate the probability of y, so it will be equal to probability of y intersection x2 plus probability of y intersection x3 plus probability of y intersection x4. Clear? Now, if we apply the multiplication rule to this, what we can write? So this probability of y intersection x2 can be written as like this: probability of y given x2 into probability of x2. Similarly, this term can be written it like this by multiplication theorem of probability, and similarly it can be written like this. So this equation 8.11 is the equation for the total probability. Is it clear to everyone? Yes.
Yes, sir.
Okay, now let's move
Yes.
to the okay. So now let's move to the next theorem, that is Bayes theorem. Now, Bayes theorem is just related to this total probability theorem. Uh, Now, consider this situation that consider this situation that we have to find the probability of x3, and it is given to us that event y has already occurred. So what do you have to find? We have to find probability of x3 given y. This is you have to find. Okay. Now this probability is a conditional probability. So we will apply the formula for conditional probability, that is probability of x3 intersection y divided by probability of y. Clear? Now, x3 intersection y means this, and probability of y means this complete part. Okay. So, probability of y, we have already calculated it using total probability theorem. So, just put this term here, and this will create a formula for Bayes theorem. Okay. So, here properly we can see it like this. So, if we have to calculate the probability of xi given y, so it will be equals to basically probability of xi intersection y, which is equals to, by multiplication theorem, probability of y given xi into probability of xi divided by this probability of y, which we have already seen in the total probability theorem. Okay. So this is the Bayes theorem. It is also you have studied in your 10+2. Okay. So till now, I have covered some of the basic concepts of probability. So let me revise this, and then we are going to solve some of the examples from Schumann series. So what we have discussed till now, we have seen random experiment, sample space, what are the classical frequency and axiomatic approaches of probability, what do you mean by mutually exclusive events. We have seen the definitions and some of the postulates of axiomatic approach. Okay. Now, the conditional probability, what is conditional probability of x given y? We have seen this. Joint probability, independent events, total probability, Bayes theorem, and all these things we have seen till now. Now we will move with some of the examples. Okay. Okay, so just read this example one, and then I'm going to explain, or let me tell you whether you are able to solve this or not. Just give me a moment. Okay, so have everyone seen this example? So it is a simple problem.
Yes, sir.
In in experiment, rolling six faces of dice, find out the probability of event of outcome divisible by 3. So it is just class 10th question. Event 1 is the number divisible by 3, and it is 3 and 6. So the probability will be, what will be the probability of this event 1? Just tell me.
2/6.
2 by
1 by
6.
3.
Correct, correct,
1 by 3.
correct. And in case of second, it will be 1 by 2, correct? 3 by 6 or 1
1
by,
by 2.
yes, correct. And the last one, the probability will be
1.
1, correct. Okay. So this was the first example from that book, Shaman series. Now the second example is, in an experiment rolling six faces dice, find the probability of occurrence of 4 if it is known that even face has appeared. Now we have to find the probability of getting 4, and it is known, or it is given, that even phase has occurred. So this is the example of conditional probability. Here we have to find, first let us define the events here. Okay, now we have to find the probability of getting 4. So let us consider x as getting 4. Okay, getting 4 is our event x. Okay, now what is given to you? It is given that even phase has appeared. So consider this event as y. So event y is even phase appeared. This is your event y. Okay, now you have to find the probability of x, and given that event y has already occurred. So we are going to apply conditional probability here. So this will be probability of x intersection y divided by probability of y. Now, first we have to write the set of element of x. So it will be only 4, because getting a 4 is event x, and the elements of y will be 2, 4, and 6. Okay.
6.
Yes, correct. So what will be x intersection y? It will be only 4. Now the probability of x intersection y will be 1 by 6, whereas probability of y will be 3 by 6. Correct. So the answer will be 1 by 3. So this will be the final answer of probability of x given by. Okay, so here you can see the solution of the book also, or you can simply use this logic what I have explained you here. Okay, so the second example is clear to all of you.
Yes,
Yes,
sir.
sir. Yes.
Okay, now let's move to the third example. Okay, so in the third example, the question is, the probability of train arriving on scheduled time is probability of x uh, is equals to 0.95. Here, obviously, x is the train arriving on scheduled time. This is our event x. Okay. Now, the probability of train departing at scheduled time is probability of y, which is given it like this. So obviously, train departing at scheduled time is our event y, and its probability is given to you. Also, probability of train arriving on time and departing on time. So it is the probability of X intersection Y, that is 0.6. You have to find the probability of train departuring on time. So train is departuring on time. You have to find this probability. Okay. So one more thing, it is given that if it has arrived on time, if it has arrived on time, so you have to find the probability of Y, because event Y is defined as departuring at scheduled time. Okay, so you have to find the probability of Y and it has arrived on time. It means given X. So here we have to find probability of Y given X. So it is a simple conditional probability based questions, and you have to just simply apply this formula: probability of X intersection Y divided by probability of X, and both the values are given to you. X intersection Y is 0.6 and probability of X is 0.95. So just put the values here and you will get this conditional probability of Y. Clear? Similarly, just read the second part of this question. Okay, so the second part says that similarly, probability of train arriving on time. So arriving on time means we have considered this as event X when departed on scheduled time. When departed on scheduled time means this part is given to you or this event is known to you. So here you have to find probability of X given Y. So simply use this conditional probability formula and you will be able to find this probability. Okay, so this example to clear, this example is clear to all of you? Confirm?
Yes, sir.
Okay. So let's move to another example, that is example 8.4. So this example, you all are going to solve this example. So just read the example and tell me the answer. I am hiding the solution. Okay, you are just able to see the question. Okay. Okay, so just read the question and try to solve this question and do let me know what is your answer. I can help you in reading this question. So ITM Gurgaon has ITM Gurgaon, the statistics of male and female employees department wise is as follows. So a table is given to you. There are three departments. First one is CSC, second is EC, third one is MEC, and the male and female faculties from each department is given to you. And you have to find the probability of meeting a female employee of mechanical department. So here the events are already defined. So this is the part of solution basically. So this part is also should be done by you only. Okay. So the event X they have already defined. Female is chosen. Y is employee of ECE. Z is employee of CSC and W is employee of mechanical department. Now just read the question and tell me what we have to find here. Probability of what? What should be the expression? Tell me. Yes. Anyone is able to decode the question and tell me what we have to find here? Which probability we have to find here?
Sir, female employee given from mechanical department.
So
X by
just
W, sir.
probability of X
Given
given
W.
W. Correct. Okay. So we have to find the probability of female employee and from mechanical department. So it is the given event. Okay, so we have to find probability of x given w. Correct. Now, probability of x given w, the conditional probability formula will be like this: probability of x intersection w divided by probability of w. Okay. Now, tell me the values. What will be the value of numerator? Probability of x intersection w. Use pen and
1
paper.
by 4, sir.
Yes. Okay, 1 by 4. So let's see. Here x is female is chosen. So this is our event x. Okay. W is mechanical department. So this is W. Okay. So the x set x contains these elements and set W contains this elements. Okay. So the intersection will be 5. So 5 comes in this 5 divided by total. So total, how many persons are there? Total there are 80. So 5 upon 80 will be in numerator. Is it clear? Just confirm. Whereas in denominator P of W, so W is mechanical. Okay. So how many mechanical faculties or employees are there? That is 20. Okay.
Okay.
Divided by all possible, that is 80. So it will be 20 upon 80. Okay. So here you will get 5 upon 20. So the answer will be 1 upon 4. Just confirm, is it clear to all of you or not?
Yes, sir.
Yes, sir.
Okay. Okay. Now, yes, so the final answer is here, probability of x given now. That is 0.25. Okay. Now, let's move to another example. Now, just read this question. Okay. So the question says that box 1 contains 5 red, 10 blue balls. Box 2 contains 10 red, 15 blue balls, respectively. Randomly, one box is selected and ball is picked up. Find the probability that picked up ball is blue. Okay. So, this question belongs to that total probability topic. Okay. So, first we have to find the probability of box 1 selected and probability of box 2 selected. So, obviously, we have two boxes and the probability of selecting each box will be 1 by 2. Okay. Now, here we are defining the event B as the picking up blue ball. Okay. So, we have to find the probability of B. Okay, probability of picking up the blue ball. Now use the total probability theorem. So the total probability theorem says that probability of B is equals to probability of B given B1 into probability of B1. Now just let me explain you this equation. Okay, what does this means? This means if we are selecting box 1, so first we will find the probability of selecting box 1, that is B1. And when the box 1 is selected, it means given B1. Okay. Then the probability of getting B, that means probability of blue ball. So, okay. So simply what we can say that probability of selecting box 1 into probability of blue ball selected from box 1. So this will be the first part. Okay. Whereas in the second part, probability of box 2. Okay, so if box 2 is selected, now what is the probability of selecting blue ball from box 2? Okay, so just add these two things and you will get the total probability of selecting a blue ball. Okay, so this theorem is nothing but total probability theorem. Okay, so these probabilities are given to you, probability of B1 and probability of B2. Now you have to find this term, that is probability of B given B1. Now tell me what will be the value. Okay, it is already given to you. It is here. You can see it is 10 upon 15. Why is 10 upon 15? Because in box 1, we have 10 red balls and sorry, 5 red balls and 10 blue balls. Okay. So the probability of selecting one blue ball out of these 15 will be 10 upon 50. And similarly, from box 2, the probability of selecting a blue ball will be, we have 15 blue balls in box 2 divided by total number of balls, that is 25. So this probability will be 15 upon 25. So we have calculated all the things from this equation. Now just put the values here, all four values here, and you will be able to find the total probability. Okay, so that will be your answer. Is it clear to all of you? Just check and let me know.
Yes, okay.
Okay. Now let's move to the last question from this probability, basics of probability, that is based on base theorem. Okay. Uh, okay, so this is example 8.7. The example says that Maruti Udyog Limited Gurgaon produces 35% Maruti 800 car, 45% Alto car, and 20% Wagoner every year. Okay, so the number of individual cars produces in terms of percentage is given. Okay, it is observed that 2%, 5%, and 3% of above model are found unsatisfactory to the standard set. Okay, so how many are unsatisfactory? It is given to us. Yes. Anyone has any doubt? Okay. Find the probability from the from the finished car that they do not meet the standard. Okay, so we have to find the probability that the finished car do not meet the standard. Okay, so first we have to define the event. So the event A is car does not meet the standard. Event B, car is a Maruti 800. C is car is the Alto. Car is the Wagoner. Okay. Yes, so anyone has any doubt, they can ask. Okay, so first we have to find the probability that the finished car that do not meet the standard. Okay, so we have to calculate this probability of A, that car do not meet with the standard. Okay, so probability of A, so we are going to apply, first we are going to apply the total probability theorem. Okay, so first we will select the probability of B. Now what is B? That the car manufactured is a Maruti 800. Okay, now after this we have to apply probability of A given B. Now if the car manufactured is 800, what is the probability that it does not meet with the standard? Okay, then we have to find the probability of C. Now what is C? Car manufactured is an Alto. Now, if the Alto car is manufactured, what is the probability that it does not meet with the standard? Similarly, probability of D, which is a Wagoner, and probability of A given D. So three different situations are there, or three different exclusive events are there, mutually exclusive events are there, B, C, and D. Okay, now it is given to us. What is given to us? That probability of B, probability of manufacturing a 800 car, Maruti 800, probability of manufacturing Alto car, uh, probability of manufacturing Alto car, and probability of manufacturing Wagoner. Okay, all these individual probabilities are given. If it is an Alto, what is the probability of getting a defective or not standard car? Similarly for 800 and Wagoner, all these probabilities are given to you. Just put all the values to the total probability theorem and you will be able to find the total probability of getting a non-standard car, or the car which does not meet with the standard. Okay. So the first part is clear to you. 8.7 total probability is applied here. Yes.
Yes, sir.
Yes, sir.
Okay. Now the next example 8.8 is based on this 8.7's results only. Okay. Now in this question, what the question says that using Bayes theorem, find the probability of auto car found not meeting the standard from the solved problem 8.7. Okay. Now we have to find that the probability of auto car that does not meet the standard. So this is given to us. That does not meet with the standard. And we have to select the probability of alto car. So selecting a probability of alto car means probability of C we have to find. And it is given that it was found not meeting the standard. It means what is given to us? Probability of C given what? Which letter comes here in this place?
A.
Yes, so we have to find probability of C given A, correct? Okay, so it is also written here. So we have to find probability of C given A. So probability of C given A is probability of C into probability of A given C. That is nothing but probability of C intersection A. Okay. Now divided by the total probability or the result we have calculated in previous example. I think it was 0.0355. So you need not to calculate all these things again. Just denominator will be 0.355. Whereas in numerator, probability of C, this probability of C and probability of A given C is already given to you in the first part of this question. Okay, so probability of C, it means selecting an alto car, that is 45%, 0.45. And A given C, A means not standard car, given C means from alto. So it is also given to you 5%. So just put these values here, 45% and 5%, and further you will be able to solve this Bayes theorem problem. Okay. Okay, so till this part, we have gone through some of the basic concepts of probability, conditional probability, Bayes theorem, total probability, and the questions from this. And we have solved almost all the solved examples from the book Showman series. Okay, so the topics we have already covered here is this probability, conditional probability, and related that. Bayes theorem, total probability, all that. Now we are going to move with the random variable, continuous and differential and discontinuous random variable, the probability distribution, cumulative distribution function, density function, and all. So let's move to the next topic of today's class, that is random variable. Okay. So here the random variable is defined. Now let us simplify this complete statement or say a paragraph. Uh, Random variable is simply a function that maps every outcome of sample space in a real number line. Okay, so let me explain you with an example. Uh, Consider a random experiment of tossing a coin. So if you toss a coin, you will get two possible outcomes. Either you will get head or you will get tail. Okay. Now let us define a variable and call it as random variable. And let us consider this random variable is x. Now this random variable x says that for head you will get rupees 100, and for tail you will lose rupees 100. Okay. Now this x depends on the elements of sample space or the outcome of that experiment. Okay. If the outcome of experiment is head, then the value of x will be 100. If the outcome of experiment is tail, then the value of this then this random variable will be minus 100. So basically, This X is mapping the element of sample space in a number line. Means these values are real numbers. So you are mapping these values on real number line. Or in a simple way, you can define random variable as it is a real valued function whose input are or whose domain is H and T, head and tail. Oh, sorry, H and T for this experiment. In general, we can say the element of sample space. Okay, so random variable X is a real valued function whose domain is the element of sample space. This is one of the example. Okay. Now let's move to one more thing here, that this example is a you tell me, this random variable is an example of discrete random variable or continuous random variable? Just try to answer this. The random variable, this in this example, is an example of continuous random variable or discrete random variable? Yes, anyone? Discrete or continuous? Just look at this. Yes,
Discrete, sir.
yes, correct. It is an example of discrete random variable. Now, what could be an example of continuous random variable? So for that, let us consider a wheel of chance. Okay. And in this wheel of chance, the numbers are marked like 0, 12, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, and 11. Okay. And suppose this arrow is like this. So if we spin this arrow may point out at 12 or at any point in between 12 to 1. That means 0.0121, any point in between this. Similarly, in between 1 to 2, and so on. So this arrow may get stopped at any number between 0 to 12. Okay, and that number can be an integer or it cannot be an integer. It may be pointing out at 1.1, it may be pointing out at 1.2 or at any value. Okay, so this random experiment is defined like this. Okay, now what are the element of sample space in this experiment? So the sample space will be like 0 to 12. Okay, here 0 will not be included because 0 is not marked here. In the head it is marked as 12. So when the arrow passes the 12, it will be like 0.01 or any number which is just greater than 0. So 0 is not marked here. So 0 will not be included, and the 12 will be included because the arrow uh, can point out at exactly 12. Correct? So here we are getting a continuous sample space which contains all the elements from 0 to 12, not including 0, but including 12. Okay. Now, in this case, let us define a random variable x. Okay. So, x is the number which is the square of s. S means the element of sample space. So, if the arrow is pointing at 1.1, so it will be 1.1 square. If the arrow is pointing at 1.2, it will be 1.2 square, like this. Okay. So here what we will get? We will get a continuous random variable for any value from, let us consider this as x-axis as s and this y-axis as capital X, which is x of s. Okay, random variable. So if you will get 0, so we are not able to get 0 here. Okay, we are not able to get 0 here. So for x is equal to 1, we will get 1 square is 1. For x is equal to 2, we will get 4, like this. Okay, so the plot of this random variable will look like this. For for s is equals to 12, we will get 144 like this. Okay, so it will be a continuous random variable like this. Okay, whereas it is a discrete random where we are getting only two values, that is plus 100 to minus 100 like this. Okay, I have written opposite here, minus 100 to plus 100. Okay, so these are the two types of random variables. Now, let us consider one more example from the book Shamil series. So this is example 8.11. The example says that let us consider rolling a dice as an experiment. Okay. Find the random variable if the event is expressed as functionally x zeta I is equals to 10i. Okay. So here zeta I is nothing but the outcomes of sample space. Okay, and the sample space is defined like this: zeta 1, zeta 2, zeta 3 up to zeta 6. Okay, functional relationship expressed as, so the relationship is already expressed as 10i. Okay, so here the values of I are 1 2 3 4 5 6 like this. So for zeta 1, okay, I is equals to 1. So when we put I is equals to 1 in this expression, we will get x of zeta 1 is equals to 10. For I is equals to 2, we will get x of zeta 2 is equals to 20, because 2 into 20. This is zeta I. So this is not 1, this is I. Okay, so like this. So that's it. This row basically shows you the random variable. That's what you have to do in this example 8.1. Is it clear to all of you? Yes, confirm.
Yes, sir.
Yes, sir.
Okay, now let's move to the next part, that is probability distribution function. Okay, before explaining this probability distribution function, I think I have to consider one more example from my own. Now, consider an experiment of rolling a dice. Okay, so we are considering an experiment of rolling a dice. So the sample space will be 1, 2, 3, 4, 5, 6 like this. Okay, now consider define a random variable x. X is equals to s square. Okay, means whatever is the outcome of experiment, the random variable is square of that outcome. Okay, so in that case, the value of x or the value of random variable will be, what will be its value? Just tell me. Just tell me, what are the values of random variable x here?
149,
149,
Yes,
16,
6,
25, 36.
1625.
36. Correct. Now, if it is asked to write the probability distribution for this random variable, what I'm saying that probability distribution of this random variable x. So probability distribution is a table which contains the elements of random variable and their respective probabilities. So what is the probability that the value of random variable is 1? Tell me. What is the probability of this? It is 1 by 6. It is equal to the probability of getting 1 in the sample space. Okay, now what is the probability that x is equals to 4? It is also 1 by 6. Probability of getting x is equal to 9. It is also 1 by 6, 1 by 6, and so on. Okay, so this table is nothing but probability distribution function for random variable x. Correct? Okay, so this is what probability distribution. Now, here we are looking at probability distribution function. So basically, there is a gap between this random variable and this next topic, probability distribution function. Before starting with probability distribution function, we have to know what is probability distribution. Okay. Now, the probability distribution. Okay. Just a second. Okay. So for probability distribution function, first we are understanding what is cumulative distribution function. So this is cumulative distribution function. It is denoted by F capital X under bracket X. Okay. So this is the notation. Here capital X is the random variable and this small x is the element of that random variable. Now, what does this cumulative distribution function shows? So, if x of capital X of x is given to you, it gives you the probability of x less than or equals to small x. Now, let me explain you with this earlier example. Suppose I asked you to find fx of 9. So just go through this definition of cumulative distribution function and let me know what is the value of this. What should come here? Just tell me. Yes. Anyone? Or I have to explain this?
The probability of 1 and 4.
You're missing one more thing. You have to consider the probability of
Equal
9
9
also.
also. 9 also.
Yes, correct. So this will be the probability of x less than or equals to 9. So you have to consider the probability of 0 plus sorry, not 0, this is 1. So probability of 4 plus probability of getting 9. So the probability is 1 by 6 plus 1 by 6 plus 1 by 6, correct? So that will be 3 by 6, correct? Okay. So just understand this. If I am plotting the probability like this, just let me show you. Suppose if you are plotting this cumulative distribution function fx of x, okay, in a graph, okay. Now, the value of x is, the first value of x is 1, okay. So what is the value of fx of 1? What is the value of fx of 1? Tell me. Just tell me what is the value of fx of 1?
1 by 6.
Yes, it is probability of x less than or equals to 1. That is equals to 1 by 6. Now, what is the probability of x of 4? Because the next element is 4. Tell me the probability.
1 by 6 plus 1 by 6.
Yes, so it will be 2 by 6. Now the fx of 9, it will be 3 by 6. We have already calculated. Fx of 16, it will be 4 by 6, like this. Okay. And what is the probability of fx of 36? Tell me. Fx of 36. Just tell me what is the
1.
value of this? Yes, its value is 1. Now tell me fx of 100. What is the value of this? Yes, anyone? Value of this fx of 100.
Sir, it would be 1, but considering till 36 only.
Yes, it will be 1 because it means probability of x less than or equals to 100. So we will add all the probabilities before 100, that will be 1. Okay. Now, can anyone tell me probability of x of 0? Distribution function when x is equal to 0. Tell me. It means probability of x less than or equals to 0, correct? Just tell me this value. No one?
0.
Anyone? Yes, the value will be 0. Okay. So if I plot this as a graph, so here in x-axis, the values are values of random variable x, that is 1, the next value is 4, the next value is 9, the next value is 16, the next value is 25, and the next value is 36, like this. So before 1, the probability is 0. So it will be like this. After 1, the probability is 1 by 6. Okay. So here it will be 1 by 6. After, uh, yes, just a second. Yes, after 4, it will be like this. Okay. After 9, it will be like this. After 16, it will be like this. After 25, it will be like this. And after 36, just let me tell you, after 36, it will go like this. So 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, and 6 by 6, which is 1. And it will be continued like this. Okay. So the graph of which function it is? It is the graph of probability distribution function. So the graph of probability distribution function will look like this. Now, what you can analyze with this graph? That in the leftmost part, the value will be infinity, whereas in the rightmost part, the value will be 1. So the value of function will be minimum 0 and maximum it will be 1. Okay. And since it is a cumulative distribution function, cumulative means the probabilities are getting accumulated, they are getting added. So initially it was 1 by 6, now it is added with another probability, added with another probability, and so on. So the probability will be always increasing in this situation. Hence, the function will always be an increasing function. It will never become a decreasing function. Correct? Because the probability is never negative. Is it clear to all of you? Just tell me.
Yes, sir.
Yes, sir.
Okay, because if you understand this, you will be easily able to understand the properties of cumulative distribution function. So here the properties are written fx of x, which is also called as simple or simply distribution function. Means if only distribution function is given to you or the cumulative distribution function to you, both mean same. There's no difference in that. Okay, exhibits the following properties. The first one is fx of infinity is equals to 1. Is it clear? I have told you from the graph, at the rightmost, the value of this distribution function is 1. Clear? Yes.
Yes, sir.
Yes, sir.
Fx of minus infinity, in the leftmost, it will be 0. Okay. And fx of x is always in between 0 to 1. From the graph, it is clear. The probability is always in between 0 to 1. Okay. The value of this distribution function. Now this is one of the most important property. Okay, I lost that page. Uh, Yes, so this is one of the most important property which will be used in numericals. So if you want to calculate the probability of x1 to x2, okay, so that will be calculated like this: f of x2 minus f of x1. For example, let me tell you, you suppose you have to find, with this example only, suppose you have to find the probability of x. Okay, in between, suppose for this example we have considered 4 to 25. Okay, 4 to 25. So how we can calculate? We will find fx of 25 minus fx of 4. Now what is fx of 25? So I think fx of 25 I have not written here, but it will be 5 upon 6. So this will be 5 upon 6. This will be 5 upon 6 minus fx of 4, that is 2 upon 6. So the value will be 3 upon 6 like this. Okay, so whenever it is asked you to calculate the probability of any random variable in between some points x1 and x2, you simply need to calculate the probability distribution function over the higher value of this random variable minus the at the lower value of random variable. That will give you this probability. The only condition is x2 should be greater than x1. That's it. Okay. The fourth property you can simply understand from this graph. As you can see that the graph of density function is always increasing. You can see here the graph of density function, sorry, the graph of distribution function, cumulative distribution function is always increasing. So this property shows you the same mathematically. So probability of x of x1 is less than or equals to fx of x2 when x2 is greater than or equals to x1. That's it. Okay. Now the next part, if x is discrete random variable, the distribution function can also be written like this. Can anyone tell me what? Okay, look, this is probability of x is equal to xi. Now, can anyone tell me what is this u of x minus xi? Yes, anyone try to answer this? U x of xi?
Unit step function.
Correct. It is a unit step function. Correct. So we have already seen this graphically here. We have calculated all the probabilities here. You can see here we have calculated all the probabilities and we have plotted this probability. So basically you are getting a staircase waveform. That is nothing but the combination of unit step functions with different shifting. Like here we are shifting with xi. Just a second. Okay, yes, in this page. X minus xi, probability of x is equal to xi. So nothing but it is like this. So this is distribution function. So what is random variable? What are the properties of distribution function? How the distribution function or cumulative distribution function will look like? Is all these topics clear to all of you? Just acknowledge so then we can move in the next topic.
Yes, sir.
Yes, sir.
Okay, now let's move with some of the examples. So we have already gone through the example 8.11 from Schaumann series. Now let's move to the next example, that is example 8.12. It is based on the results of 8.11. So here you have to find the cumulative distribution function fx of 30. Okay. Here the x is defined it like this, and the probability of zeta I is 1 upon 6. So same as what we have discussed. So probability of each random variable is same, 1 by 6, 1 by 6, 1 by 6, 1 by 6, and 1 by 6. And you have to find this distribution function, cumulative distribution function. So just tell me what will be your answer in this case. Just tell me the answer. Anyone? Fx of 30. What does this means? This means probability of x less than or equals to 30. Correct? So you have to add the probabilities of all these events. That is 1 by 6, 1 by 6, 1 by 6, 3 times. So you will get 3
3
by
by
6.
6.
Correct? Now, just one thing here, it is changed. You can see so just one difference here. You can see here here the solution added this u of xi minus zeta I also. So here it is nothing but unit step function, shifted unit step function. So that's why p of zeta 1 u of 30 minus 10. Okay, because zeta 1, the value of zeta 1 is 10 in the first case, and so on. So it is written like this. So that part is also correct. You can use that also. Here we have ignored these values because here the value of u of minus 10 will be 0, u of minus 20 will be 0, u of minus 30 will also be 0. Okay, so it is written like this. Now, one more problem. Just tell me the answers here. Okay, uh, answers of this part. Just tell me the answers of this part. Example 8.3, first part. What will be the answer? And one more thing, how we can express this probability of capital X greater than or equals to 10, less than or equal to 30, how we can express this in terms of cumulative distribution function. Just tell me how we can express it like that. Fx of what?
30 minus
Correct. Very good. Fx of 30 minus Fx of
fx of 10.
correct. So we will express it like this. Now fx of 30 we can calculate, it is 1 by 2, and fx of 10 it will be 1 by 6. So the answer will be 1 by 2 minus 1 by 6. So 2 by 6, anything, whatever will be there. Now tell me what will be this. Tell me the probability of this.
One by six.
1 by 6. F it is not included 20 to 30. Yes, it will be 1 by 6. I think let's check the solution. Solution of this. This is example 8.13. Okay, so let's check the solution. The answer of second part is it is 0. Yes, that's why I have doubted in this part. Okay, so now why it is 0? Now just understand this. What is the difference here? It says that you have to find the probability where x is greater than 20. The 20 is not included here. And x is less than 30, where 30 is not included here. Now, tell me any value of x which satisfies this condition that the x is greater than 20, but it is less than 30. There is no value of x is here. Correct? So the favorable outcome or the value for this is 0. That's why the probability is 0. So this one is little tricky. So everyone able to understand this? Just acknowledge the second part.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. Okay, so this was the distribution or cumulative distribution function. Now let's move to the density function. Now we are
So please
going.
repeat the second part.
Okay, so in the second part, we have to find the probability of x greater than 20 but less than 30. It means x should be greater than 20. 20 is not included here, and x should be less than 30. 30 is not included. So is there any number in x which is in between 20 to 30? Nothing is there. So no
Yes,
element
sir.
of x is possible. That's why it is 0. Okay?
Yes, sir. Yes, yes.
Okay. Now let's move to the density function. So we are going to some complex forms of functions right now. So you have to remember the previous terms and everything we have discussed till now. Okay. So in the density function for a continuous random variable x, it is also called as PDF in short, probability density function. Okay. It is denoted by small f of x. Okay, small f is for density and the capital F is for For which function?
Cumulative function.
Cumulative distribution function, CDF, or simply called as distribution function. So PDF is first order derivative of CDF. Clear? So this is PDF and this is CDF. Clear? Now, you might have already studied that the derivative of a step function is. What is the derivative of step function? Can anyone tell me? Suppose this is a step function. If I differentiate this step function, unit step function, so what will be its derivative? Tell me. Yes. No one remembers. Okay. Let me tell you something else, or let me ask you something else. What does derivative gives you? डेरिवेटिव आपको क्या देता है? किसी भी फंक्शन का डेरिवेटिव आपको क्या देता है? What does derivative gives you? Derivative of a function gives you the slope of that function. Clear? Now, for this horizontal line, the slope of this line is 0. Slope is
0.
denoted by 0. Correct? So if I differentiate this line, we will get 0. So its derivative will be 0.
0.
But the unit step function start from this. So this is a vertical line and the slope of vertical line is infinite. So at this point, the derivative will give you an impulse function. Is it clear to all of you? Okay. So the derivative of unit step function u of t or u of x, whatever you are representing it like this, the derivative will be del of x. That is impulse. So everyone studied the impulse function? Let me just tell me. You have studied impulse function, step function.
Yes, sir.
No,
Okay.
sir.
Okay, so yes or no, whatever is the condition, let me tell you some basics here. Uh, so starting with the ramp function or ramp signal. So ramp function signal is denoted by R of x. It is a straight line. The function looks like a straight line. Okay. So if we differentiate the ramp signal or ramp function, we will get a step function, because the ramp function, the slope is constant, and the derivative will become constant. So that's why it look like this. And when we differentiate this step function, we will get an impulse function. Okay, so these are some basics, which is already, I think, in the first unit of signals and systems that you must know. So del t is nothing but d by dt of, I have represented it as t. You can represent it as t or x, anything, whatever you're comfortable with. So d del of x, that is unit impulse function, is derivative of unit step function, like this. Okay. So these are some basics here. Now, what I'm telling you, all these basics in case of density function, because again, I'm going to the previous graph which we have drawn here. Okay, so just look at this graph. This was the graph of CDF, cumulative distribution function. And what I'm telling you is density function. So if I want to find the density function or want to plot the density function, then I have to differentiate this graph d by dx of this. Okay, so when I differentiate this graph, just understand what I will get. Here I will get an impulse of magnitude 1 by 6. Clear? At 1. Now here again the slope is changing. So again I will get an impulse of magnitude 1 by 6 at 4. Here again it is changing. So I will get an impulse of slope 1 by 6. So at 16 also, this is 9. At 16 also I will get 1 by 6. At 25 also I will get 1 by 6, like this. Okay, so this is the plot of PDF. What is PDF? What is PDF?
Probability distribution function.
Probability density function.
Exactly.
This is distribution and this is density. So the density simply means how many numbers or what is the probability or how the probability is distribution over this interval. This is what the probability density function. So I have shown you graphically how the density function will look like. Now let's understand some of the properties of density functions. Now, clearly, the density function is always greater than or equals to 0. It cannot be negative. Obviously, it shows you the probability, and probability is never negative. Okay, the first property. The second property is this one of the most important property, and we will do numerical based on this also. So the second property says that integration of minus infinity to infinity fx of x is equals to 1. Okay, so what does this means? This means if we integrate means accumulate. If we add all the probabilities from here, we will get sum as 1. So integration is in discrete form, it is nothing but summation. So this is for continuous random variable. In case of for discrete random variable, we can write it also like this: summation minus infinity to infinity fx of suppose n, that is equals to 1 for discrete. Okay, for in example we have seen that. Okay, so most important property. Now the next property is okay, so if I consider x as a constant lambda, then this will give you the distribution function over that value. Suppose if you have to, if you are integrating the same question I'm considering, minus infinity to, let us consider 4 f uh, minus infinity to infinity, and let us consider is fx of 4 d4, like, but here it is constant. So just leave it without example. Just understand that for lambda, for some specific value, we will get this distribution function. Okay, now the next is probability of random variable x. Suppose we have to find for the interval x1 to x2. So this we can find by integrating the density function over the interval x1 to x2. Okay, now the fifth part is the discrete form of density function. So all these are the properties of probability density function. Okay, now let's move to the examples from Shaman series, the same book. Okay, and we will see example 8.14 based on PDF, that is probability density function. So this example says that find the constant k for the density function which look like this or defined like this: f of x is equals to kx square, where the values of x are in between 0 to 2, elsewhere it is 0. Okay, and also we have to calculate the probability of x greater than 1 and less than 2. Okay, so we, from second property, we know that integration of PDF over the interval minus infinity to infinity, it gives you 1. And since the function is defined for the values of x between 0 to 2, so this limits gets changed from 0 to 2 instead of minus infinity to plus infinity. Now this density function is kx square, and the overall value you will get 1. So here k is obviously constant. So if we integrate x square, we will get x cube upon 3 for interval 0 to 2. And when we put the limits upper and lower, we will get the value of k as 3 upon 8. So is that clear to all of you? This part is solved from the property 2 of probability density function. That's it. Just you have to put the values. Is it clear to all of you? Confirm?
Yes, sir.
Okay. Now, in the second part of this question, we have to find the probability of x greater than or greater than 1 and less than 2. So it is also from this property. Look at this property. The fifth property, if you have to find the probability of x greater than x1, less than x2, then simply you have to change the limit from x1 to x2. So what you have to do, you have to just change the limit from 1 to 2, and the value of k which you have already calculated in the first part of solution, put that value here and in the function, and integrate the function, and the value you will obtain after putting the limits, that will be the value of probability of x greater than 1 and less than 2. Okay, so this is the mathematical expression for that probability of x greater than 1 less than 2. The second part is also clear to all of you, just tell me. Okay. Okay, so this is one of the example of PDF and CDF. Now there are many standard PDF and CDF functions: probability, this density function, and cumulative distribution function. Different forms are there. So we already know that uh, the differentiation of CDF gives you PDF. So the first case, we are considering uniform CDF, density function. So fx of x, it is like this. When x is less than 0, the value is 0. When x is greater than or equals to b, it is 1. As we know that it starts from 0 and ended to 1. Okay, and in between it looks like this. It is nothing but that 2-point form of equation of line. When we use that form, we can able to draw this mathematical form of that one. So before a it is 0, after b it is 1, and between a to b the it is a straight line which look like this. Okay, so this is the graphical representation of uniform distribution function, uniform cumulative distribution function. Now I have already told you what is the derivative of some standard function. So when I differentiate this function, what I will get? For this part, the slope is 0. So here we are getting 0. For this part, the slope is also 0. So here also we are getting 0. But for this part, we are getting a constant positive slope. So that's why a constant positive slope is there. So the derivative of ramp will give you the step function. That's why the derivative of this part will look like this. Okay. Similarly, if you differentiate mathematically also the CDF, you will get this PDF. Okay. Now, this is one of the most common and simplest form of cumulative distribution function and probability density function. The another for different distribution and density function are like exponential function, whose mathematical form look like this, graphical representation look like this, and for PDF, the expressions are like this. Similarly, one of the most common and suitable form of CDF and PDF, which we usually used in signals in order to identify the distribution of noises in a signal, rather in the form of uh, a 1D signal or 2D signal, like a speech signal or an image signal, is Gaussian distribution. Or we can say that the noises are usually mathematically modeled as a Gaussian distribution function for PDF and CDF. Now, the interesting part here is the this CDF, that is cumulative distribution function, and the PDF, that is density function, both are same, both are Gaussian, because when you differentiate a Gaussian function, you will get a Gaussian function. So the derivative is same here. Okay. So these are some common or most popular CDF and PDF combinations. Okay, so let's move to the next part, that is expectation, or we can say mean of random variable. So the mean of a random variable is either denoted by x bar, or it is denoted by mu x, or it is denoted by e of x. So many different notations are possible for this. Okay, just a second. Okay, so this is what the expectation and mean of random variable. Now, in order to calculate this mean or expectation, the simple formula is minus infinity to infinity. This is one of the most important formula, and many problems based on this are available in the book. Okay, minus infinity to infinity x fx of x dx. You might have studied this expectation and mean of random variable in your 10 plus 2, but that was for that I think discrete random variable. Okay, in that the random variable values are given to you, the probability of each random variable is given to you, and simply what you do is you find xi into pi, and the sum of that xi into pi gives you the mean. Here also, in case of continuous random variable, you are doing nothing the same, xi into pi. So this here it is fx of x, that is density function. Okay, and integrate that over the interval minus infinity to infinity. You will get the mean or expectation of that random variable. Okay, so this is the discrete form representation of mean or expectation of random variable. Okay, so you just need to remember these form because we are going to solve some of the examples based on this, and that you must have to remember. Okay, now the next is variance. So how we calculate variance of random variable? So variance is based on mean. So simply the multiplier density function with this x minus mu x. Here mu is mean. X minus mu x whole square into fx of x. Fx of x dx. Okay, so this gives you the variance. Another form of variance is also given to you. I think I will show you one more expression for variance that will be better in order to understand. I think it is yes. This is one more form of variance. Okay, e of x square minus mu x of whole square. I think this equation will be better in order to calculate uh, variance for mathematical problems. Okay, so this are the means and variance equations. Now standard deviation, so it is simply the root of variance. That's it. Okay, so let's see some of the properties of mean and variance of random variable. Now, the first property is two random variable x and y have same PDF or equal PDF. Then their average value means mean value are same. So same random variable, same mean. Mean value will exist only when ex absolute value of e of x, expectation of x, is always a finite, means it should less than infinity. Okay, the mean can be linearly separated like this, where a and b are constant, and if the density function of a random variable is symmetric with respect to y-axis, it means if the density function look like this, okay, it means its mean is at origin, or you can say its mean is 0. So this is what the mean and mean properties of mean of random variable. Okay. Now, properties of variance. So here you can see variance x signifies the spread of PDF. You already know some basics of statistics that we in descriptive statistics, basically we study two major things. One is central tendency of data. Okay, in case of central tendency, we use mean, median, and mode. Okay, whereas the other part is dispersion of data. In case of dispersion of data, I'm talking about descriptive stats. In case of dispersion of data, we study standard deviation, variance, and I think mean deviation about the mean, like this. All these things we study in the dispersion measurement. So here it also says that x signifies the spread. Dispersion means spread of the data about the mean value. Okay. Now, variance of ax if a is constant, so we can simply use it like this. Similarly, variance of x is also given like this, which I have already shown you in one of the example, uh, we are going to solve right now. That we use this formula to calculate the variance. Here mu x is nothing but mean of that random variable. Okay. So let's begin with some other examples of this random variable, statistical values of this random variable. Okay. So in example 8.16 from the same book, Shawman series, Signal and Systems, the random variable x is expressed as density function. So this small fx of x is nothing but PDF, probability density function. Okay, and it is defined like this: for x greater than 0 its value is this, and otherwise its value is 0. Here alpha is constant. Now you have to find the expectation of x, or the mean value of x. Okay, so it is denoted by this and also by this. So simple formula: just multiply x with the PDF and integrate it with for interval minus infinity to plus infinity. Now the signal, now this density function is defined for greater than 0. So just change the limit from minus infinity to infinity with 0 to infinity. Now, in order to integrate this expression, this alpha is constant, so you can take alpha outside this integral. So you'll get integral 0 to infinity, and here the values are x x e raised to power minus alpha x dx. So obviously you have to apply integration by parts here. So when you apply integration by parts, alpha is constant, so you can take outside this integral. So the first function, that is x into integral of second, so it will be e raised to power minus alpha x divided by minus alpha minus complete integration, the derivative of first, so derivative of x will be 1, and integration of second, so integration of this part will be e raised to power minus alpha x upon minus alpha dx. It will look like this. So what I'm doing, I'm just integrating using integration by parts here. Okay, so further it will be minus alpha x e raised to power minus alpha x divide, so sorry, this alpha is in denominator. Okay, this will become positive, and further the integration of this part will be e raised to power minus alpha x divided by minus alpha square, because e raised to power minus alpha x is integrating two times. The limit is from 0 to infinity, and after this, once we take this alpha outside this, so after simplification, it will be minus x e raised to power minus alpha x minus e raised to power minus alpha x upon alpha, and limit is from 0 to infinity. Once we put, yes, any doubts? Once we put the upper limit, so these values will become 0. For lower limit, this term will become 0, and this term e raised to power 0 is 1. So here we will get only minus alpha, and for minus lower limit we will get only 1 by alpha. So just simply integrate this and apply the limits. You will get the mean value of that random variable. Is it clear to all of you? Just let me know how we have calculated the mean. Just use this formula to calculate the mean, applied the PDF, and use some mathematical operation like integration and limits, and we got the mean. Okay. Now further we have to also find this value, e of x square. So simply what you have to change here, instead of this x, just use x square, and that will give you expectation of x square. That is second order moment basically. Okay, so just simply put the value of density function here. This is the density function, and integrate this expression. So basically we have to apply integration by parts two times here. So once you apply that, solve this, and you will get the value e of x square like this. Okay, so I think all will be able to integrate and apply the limits here. Is it clear to all of you? Just tell me now, yes or no?
Yes, sir.
Okay. So this was the example 8.16. Now, just tell me whether you are able to solve this next example or not. Okay, just tell me whether you are able to solve the next problem or not. So the question is same, just the values are different. Just a second, why it is. Okay, so the probability density function is given to you for random variable x. It is defined for the interval 0 to 1, and you have to find mean, variance, and standard deviation. So the formula for mean of random variable is this. We have solved one more problem before this. So what you have to change here? Simply change the limit uh, from 0 to 1. So the lower limit will become 0, upper limit will become 1. Just put the value of f of x here. So the value of f of x is this. So put this value here and simplify this expression mathematically. Further integrate this expression, okay, and after integration apply the limits, and you will find the mean of this random variable. Clear? So that's it. This is how we calculate the mean when the density function is given. Now next we have to find variance. So for variance we will use this formula, okay, and for this we have already calculated the second part, and we have to calculate the first part. So for first part, just replace x with x square and put the value of fx of x and simplify that expression. After simplification you will get the expected value of x square like this. Now after using these two values, or use these two values and put the values here. Yes. Any doubts? You will get variance. And the root of variance will give you the standard deviation. That's it. So try to solve this problem. It is simply a mathematical problem. You just have to put the values of density function, apply the limits, and use formula for mean and variance. Okay. Now, till this point, we have discussed about the random variables, distribution function, density function, and the statistical values related to distribution and density function and random variable, like expectation, that is also called as mean, okay, variance. Now these all are called moments. Basically the mean is first order moment and variance is second order moment under certain conditions. Now these all are one random variable. Any doubts? Yes. Yes, anyone has any doubt, they can ask. Venkatesh Lakshan, any doubt?
No, sir.
Okay. Okay. So after this, we will see a little bit about what is two random variable. So simply, if we have two random variable, we will get a joint distribution function. You have remember what is distribution function? Okay, so in case of joint distribution function, we have two random variable x and y, and jointly how their distribution function will be like. Similarly, the derivative, the partial second order derivative of joint distribution function will give you the joint density function. Okay, and the relation between joint distribution and density function is like this by these equations. Okay, it is similar to the what we have discussed with the random variable. Similar to that, just we have two random variable, so everything comes jointly. Similarly, the derivative, the integral, the notations also gets changed. Okay, now some of the properties of joint density function and distribution function. So this here you can see the joint density function is always greater than or equal to 0. Obviously the same for the normal one variable density function. Similarly, joint distribution function of xy, uh, or minus infinity to y is 0, from x comma minus infinity is 0. Similarly for both are minus infinity to plus infinity, it is 0. So if one is 0, other one will always be one values minus infinity, another value will be 0. Okay. Another property is distribution function is always in between 0 to 1 for plus infinity. You might have remember that what I have discussed in one variable, so you can correlate that. The distribution function is always a rising function. At leftmost it is 0, at rightmost it is 1. So the same property is for that, is related to that. Okay, nothing else, just we have two random variables. So you can go through these properties and simply check the distribution and density function in case of joint collaboration. Okay, so till this we have discussed all the distribution density function of random variable. Now let's come to the random process. So in short, let me tell you what is random process and how it look like. Okay, so just this topic I have taken from separate book, that is PZ Peoples. All other topics were based on the same book, Shaman series. Okay, so here let me tell you the random process. What is random process? Okay, so the concept of random process is based on enlarging the random variable concept to include the time. So in random variable, the domain is only the element of sample space. Okay. So a random variable based on a random experiment. Okay. So it has only one independent variable, that is sample space, element of sample space. Now, if we include the time also with this random variable, it becomes a random process. So it depends on the two values. The first one is time and the second one is sample space. So it is basically denoted by xt of s. Means you can say that one dimension is added to the random variable, it becomes a random process. Okay. Now consider a random waveform x of t. Now let us consider a random waveform x of t. Okay, so x of t is like this. Okay, it is like you have tossing, you have throwing a dice. Okay, getting an outcomes at one time instant, suppose at 10 a.m. and after you are doing the same thing at 11 a.m. After that you are doing the same thing at 1 p.m. like that. Okay, so you are adding a time also in that. So that example for discrete random variable. In case of continuous random variable, let the waveform, discrete random waveform, continuous random waveform look like this, like this. Okay, for time t1 instance. Similarly, for time t2, sorry, not time t2, for first random process or random variable x1. Similarly, for second, it will be x2, means second random waveform. Similarly, x3, the third random waveform. x4 of t, fourth random waveform. So this collection or ensemble of random waveform is called random process. Now, if you fixed a time, say t1, so the amplitude of that each random waveform will be different. Like in case of first waveform, the amplitude is -1. For second waveform, it is 2. For the third waveform, it is 3, and so on. So when you fix a time, it will become a random variable. Okay, so basically what we can say that random process is an ensemble of random variable and and the ensemble of random waveforms. So this is what random process is. Now, random process can be classified as continuous random process, where we have number of continuous random waveform. Okay. It can be classified as discrete random process. So it is basically continuous time, but the amplitude are discretized, either +1 or -1, like that. The third is continuous random sequence. So we are discretizing the time and the amplitude are continuous. So this is continuous random process and discrete random sequence. So discretizing the time as well as the amplitude will gives you discrete random sequence. So these are the four types of random process you can see. Now, the next part is stationarity and independence of random process. So basically, when the statistical property of random process does not change with time, then it is called stationary random process. So if you are getting same outcomes for the experiment you are doing one time and same is repeating after 1 hour or 2 hour later, the outcomes are same and the statistical properties are not changing, that is called statistical random process. Okay, and same for the independence. It does not depends on the previous outcomes. So this is called independence, and that is measured based on the mean value, moment, and variance of that random process. Okay, so this is nothing but some statistical features. Now, one thing you must know about this stationarity, that is order of stationarity. Okay, so just let me tell you simply what is first order stationary, then you may be able to correlate with the higher order of stationarity. So if mean of random process does not change with time, or you can say uh, the statistical mean and the time averaged value of random process is same, then it is called first order stationary. Similarly, for second order stationary, the mean and variance, second order stationary is also called as white sense stationary. So if the mean and variance of random process is same, then it is called second order stationary and white sense stationary random process. Okay. And for strict sense stationary random process, the nth order movement of random process does not change with the time. Then it is called nth order stationary random process. So just go with the definition of this. You can find it here. Okay. Also in Shaman series book, it is given to you. And the last is time average and ergodicity. One more important concept you need to understand. What is time average? So if we have a random process like this, which is a collection of waveform which is changing randomly like this, if we average this waveform, we will get the time average value of that waveform. Correct? And ergodicity is if the time average of waveform and the statistical average of waveform is same, then the process is called ergodic process. Clear? So these are some of the important statistical part which we have to taken care when we are doing dealing with the random signal or in random process. So briefly, so it is already 12 noon. So what we have discussed, let us summarize today's class. And we have completed this chapter almost, this random probability, random variable, and random process. So let us summarize this. Okay, so we have started with the probability. What is probability? What is conditional probability? Discrete and continuous random variable probability distribution function, CDF, PDF. We already discussed this. Okay, joint distribution and density function. It is for two random variable, uniform and Gaussian distribution function. Stationarity. What is stationarity? What do you mean by non-stationary process? Okay, White Sane stationary process, also called as second order stationary ergodic random process. So these are the topics which we have covered, and basically the unit number 4 mostly. Okay, so we are done with this chapter. Anyone has any doubts or any questions, you can ask. And for reference, you can follow the Shaman series book. Which you can use for study. All the contents are available, and all the examples I have taken here was from that book only. So you can practice some more examples from this book. So anyone has any doubt, they can ask, or if you don't have any doubt, you can just put your attendance along with your roll number in the chat box and leave the meeting. Thank you. Yes.
For the last few topics, we have to do the definitions only or about examples and all.
No, for last few topics, the examples are not there that much. Okay, so just go through the definition and terminologies. What does that means? You should know only that part. Okay.
Okay, sir.
Okay. Any other doubts? Then you can ask. Otherwise, I can stop the recording, and after your attendance, you can leave the meeting.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Okay. Welcome.